In Lesson 1-2, you're going to be able to apply and extend understanding of rational numbers and decimal expansions to describe the characteristics of irrational numbers. So yesterday we talked about rational numbers, and now we're going to start talking about irrational numbers. We start off with square roots, okay? Squaring a number, the opposite of squaring a number is square rooting a number. So 3 squared equals 9. That means the square root of 9 equals 3. Here are some examples of perfect squares. These are all rational numbers. So the square root of 81 equals 9. That is rational. That is rational. So those are rational square roots, okay? Irrational square roots is any number that is not a perfect square root is an irrational square root. Okay, for example, the square root of 90 is irrational. That's not perfect. The square root of 32, the square root of 7, the square root of 3. None of those are perfect squares. Therefore, it is irrational. So here we get to our first example. Determine if each square root is rational or irrational. Well, the square root of 9 is 3, so that's rational. Square root of 3, not a perfect square, irrational. 8, irrational. Square root of 5, also irrational. Square root of 6 is irrational. Square root of 2 is irrational. Square root of 7 is irrational. Square root of 4 is 2, and that is a rational number. And then down at the bottom, which numbers are irrational? Square root of 25 is 5. That is a rational number. Square root of 50 is not perfect, so that is irrational. And the square root of 125 is not perfect. How you can test and see, if you plug in the square root of 125 in your calculator, you can see that it does not come out to be one single answer. Okay, are these rational or irrational? Here we go. A, that decimal terminates, so that is a rational number. B, that keeps repeating, it's 2.1, where the 1 repeats itself, so that is rational. C, there's a pattern, but there is no repeating, so that is irrational. D, you have 2.1, 2, 3, 4, where that all repeats itself, and remember, when a decimal repeats itself, that's rational. And here you have 1.803 with the 3 repeating itself, that is rational. Which number is not irrational? Assume each pattern continues, okay? Is not irrational, which means which numbers are rational, okay? Here, nothing repeats, and it does not terminate. Here it goes 2, 1, 3, 2, 1, 3, 2, 1, 3, 2, 1, 3. So that's rational. And there we have a pattern, but it does not repeat or terminate. So therefore 2 is the only one that is not irrational, which means rational. All right, here we go, a checklist. Let's see which numbers fall into what category. So 15. Okay, first of all the numbers that we are talking about, every single one is a real number. We have not gotten into imaginary numbers yet, therefore all of those are real. Okay, 15 is a natural number. Natural numbers are the numbers you start counting with, 1, 2, 3, 4, 5, and 6. A whole number, just add 0. So it's 0, 1, 2, 3, 4, 5, 6. Integers, all negative nice numbers, 0, and all positive nice numbers. Okay, 15 is in fact rational. Okay, therefore it is not irrational. A number can either be rational or irrational. It cannot be both. Okay, right here, negative 1.232, that's a decimal, that terminates. That is rational. That is not an integer because it is not a nice number. The square root of 45, okay, that is not a perfect square, and we talked about this at the beginning of this video. Therefore, it is irrational. 21 over 35 is not a nice number, but it is a fraction, and fractions are rational. Negative of the square root of 16, that equals negative 4. Therefore, it is an integer, and it is rational. Okay? -4 is a nice number. It is rational. 21 over 3, that equals 7. 7 is a natural number. It is also a whole number. It is an integer, and therefore it is rational. Remember, every number has to be rational or irrational. So what are all the possible names for 1 and 2/9? Well, it can be real. We should know that right away. It is a fraction, so it is rational. And those are all we know about that number. It is not an integer, okay, because it's not a negative nice number, 0, or a positive nice number. It is not a whole number. It's not 0, 1, 2, 3, 4, 5, and it's not a natural number. Okay, if it's not an integer, it can't be a whole number or natural number either. And that is section 1, 2.